Let's see. Let's walk over and see what kind of day it is today. Oh, somebody put something on the board. A squared plus B squared equals C squared. I've seen that before. Yeah, no, I don't know what they were to do that for, but we'll just keep on going here. Take a closer look. Who's that? Oh, Pythagoras, are you back again? I don't know where you are, but all right, I look at it. I understand that. I've seen this. We've been working with this in class. I get it. You know, we got our famous 4, 3, 5 triangle. I can see that, you know, 3 squared plus 4 squared equals 5 squared. So what? No, that's enough of you. That's take a closer look. What do you mean, take a closer look? What else is there to see? What'd you say? I'm discriminating? What do you mean I'm discriminating? Ah. Oh, you mean, oh, that could have been negative? Oh, negative 4 squared? Geez, that's 9 and 16 equals 25. Well, yeah, that's true. That's true. I could have done that. Yeah, but I don't think you should say I'm discriminating. Everybody discriminates? What do you mean everybody discriminates? That's true. Yeah. Last test I did, we did have I think a y squared equal 25. And yeah, everybody just said the square root of 25, 5. Yeah, that's true. Oh, yeah, you're right. Yeah, you're right. Not too many people remember that there's 2 answers there, plus or minus 5. That's not our fault. You're the ones that gave us, you know, that outlook about positive numbers and not thinking enough about negatives. It's not our fault, it's your fault. Right? If you presented positives and negatives at the same time, you know, if you had like said positive 5 here and negative 5 there, maybe we wouldn't be in such a difficult situation. So I'm blaming you. Yeah. Who's that? Rene's talking to you? What is he on a cell phone? Rene Descartes on a cell phone? He said that I'm using some of his understanding from way back in the, yeah, maybe he stole this from somebody else. Maybe Joe the barber down the street showed him this because, you know, I've heard that you're not the one that did that. It was one of your students. And then somebody else said, showed up in the Middle East hundreds of years before that. And somebody else said it was in East Asia before that. So, yeah. Oh, you didn't claim credit, just history. Oh, so you're actually a nice guy. Okay, that's good. All right, so we're done here. We're not done here. You're telling me to use that stuff, that Arab stuff, that algebra stuff? All right. We'll look at that. We'll go, yeah, you're right. We don't work with this anymore. We work with things like equations, like x squared plus y squared equals 25. Ah, so like you're saying here that if x was that, if this was y, and if this was z, that kind of thing. Is that what you're telling me? Yeah. And Rene's talking to you too? What the? He's plotting against you? Rene? Oh no. Oh, he's just talking to you. What do you got? Cell phones up there? Rene's not up. He's not up there. Oh, I'm sorry. But he's still talking to you. So what do you carry phones around or something? Like, we got those things now. Everybody's got them. They put them in front of them and walk everywhere. And, you know, it feels like a San Chen kind of, maybe they're doing some kind of, I don't know what it is. But everybody seems to like it. It's like another appendage. Huh. And so you're saying that Rene is telling you to tell me to plot it. Oh, to plot like 3 and 4. Yeah, he gave us that 2 ruler system, didn't he? Yeah. Where that was the y values and these are the x values. And I guess if I went over 3 for x, I could go up 4 for y, and I'd have a solution to this equation. Well, we solve equations. I just solved it. I guess I can go now. I got other things to do. It's Saturday morning. Right? I got to get to Amherst. I got what? There's more than one solution to this problem? There's more than one solution. You're telling me there's more than, you're saying I'm discriminating against? Oh, that's true. Yeah. I have to agree with you. When you're right, you're right. I could have gone down 4, right? We just talked about that. So I could have also done down 4. Oh, that's true. There are two solutions here. So I guess I'm done now. Wait, what are you telling me now? You're telling me that there's something I learned earlier that I could apply to this? Like what? You're telling me that 4x plus 5y equals 40 is the same as this? You're nuts. You got to be out of your mind. I better be careful here. I'm dealing with some things I'm not sure what's going on here. Oh, that's a product? 4 times x is a product? Yeah, some old guys have been saying always use zeros. Figure either make a zero or use a zero. I don't understand why. So you're telling me make that 0? Well, we've been doing that in class. And then, oh, so I can see the data that works here. Oh, yeah. So if x was 0 and y was 8, then if I multiplied those two things together, or if I added them, excuse me, yeah, 8, yeah, that becomes 4 times 0 is 0, 5 times 8 is 40, and if I added those, that's true. Yeah, and I guess that's a product. And you're telling me I can even do it on this side? Oh, okay, so if I make that 0, yeah, you're right. My brain worked for that. I didn't need a calculator. Now you're telling me that this thing turns into just the y-intercept and the x-intercept, and I can very quickly look at all kinds of things that work. Like if that's 10, maybe that's 9. So if that's 9 and that's an x value, that's 36, and I can find the y value that goes with that x and that y. And geez, that's another data point, and we put them all together. It kind of looks like a picture here. Kind of looks like as my x's get bigger, my y's are getting smaller. But I'm still having a problem with this thing here, 3 negative 4, because I just had a conversation with my grandson on the way to his school. He's 7 years old, and I said, well, what about the number negative 4, something like that? And he said, well, that's not real. They don't exist. And I said, why not? I said, if you walk up 4 flights of stairs, and what if you walk down 4 flights of stairs? How are you going to tell the difference? He said, well, you still walk 4 flights of stairs. And I went, okay, you got me there. I said, how about, you're in a boat and you're above sea level. What if you want to go swimming? How are you going to, tell me how far below the sea level you are when you take a dive? And so we had a nice little conversation, and, we kind of agreed that, yeah, there's no reason we can't count negatives and see where we are in the water. Oh, what am I talking about now? Oh, yeah, you told me that there's patterns here. There's patterns here. Okay, Renee's telling you to plot. Renee's plotting against you? Again? Oh, no. Oh, plot as in collect the data so you can maybe see a pattern. Oh, somebody told me seeing patterns as math is one of the goals of a good math education is to see patterns. I guess the only way to see patterns is to compare one equation to some other equation, and you said what? You can solve problems if you can see patterns? Oh, so we shouldn't just be looking at this one problem. We should be looking at the problem-solving skills and tools. Thank you, Pythagoras. You are a nice guy. I'm going to try to remember that and try to use it right here. Oh, so you're saying that x squared is a product. And that old guy keeps saying, if you can make products equal 0, so you're saying if I put my hand over it here the same way I did here, that I can use that skill to solve y squared, which is, if I'm not discriminating against negative numbers, yeah, 4 and negative 4. I guess I'm done. What? You're saying I didn't use this the proper way? Oh, that's right. It's a product. I'm supposed to put a 0 in it. And yeah, and I think I did that, and I think I put a 3 in to talk about. Oh, so I goofed. It's okay to goof in math as long as you can figure out when you goofed and correct it. That's part of the learning process. God, so let's erase that. Let's erase that, and let's put our hand over it. Then if x is 0, I guess y could be 5, and y could be negative 5. I gotta move that one over here. Okay, maybe there. So I got that, that. Ooh, you're saying I'm discriminating again? How am I oh, you're saying I'm discriminating. She said Y is crying out for the same behavior. So I guess that's 5 and -5. Well, that's 3, 5 is maybe here, -5 is here. And you're saying that there's a pattern? I'm still discriminating? How am I discriminating? Oh, you're saying that I could let X equal negative? -3, you're right, I never did it. I did +3, but I never did the negative. And -3 means 9, right? -3 squared. That gets me this. And that gets me. Oh, you're saying this is never changing, it's constant? Oh, you're saying that regardless where I draw, that's the same? Oh, so I could have drawn it further out, and I'd have to come down. And I'm seeing a little bend here, right? Because that's a constant. Oh, wow. Ooh, so that means, that means I can connect these things, huh? Ooh. Whoa, you know what? I'm sorry I discriminated on this side. Wow. That's a circle. My goodness gracious. Just playing with some numbers. So you're saying, to understand anything in math, you got to play with numbers too? Okay, I'll try to remember that. All right, so I guess we're done. We're not done? Well, I know the center is 0, 0. Right? If I don't draw any length to the side of these triangles, then I'm not getting any area. So that wouldn't solve this. 0, 0 doesn't solve that. But, it is the center, isn't it? All right, so we're done now. All right, I can get out of here. Let me erase the board for the next teacher that comes in. Thank you for helping me. I appreciate it. And that actually is, I'm trying to remember some of those things and get out of here and say hi to Rene for me and wish him well. And I guess we're not done. What do you mean we're not done? You're saying everything you learn, then you build off of, and you can do more things? Like what? Oh, yeah. Completing the square. We've been practicing that in class. I don't know why. Completing the square. Wow, that sounds like, building something in some city, building a nice square area, nice park. No, no. Oh, that's right. We're still in a math class. That's right. Yeah. Oh, well, we practiced that the other day. We did x squared plus 8x, and we said, well, how do you write that as a square? Well, you cut the sides of the rectangle, get them even, and then get rid of the, unwanted constant square. And that brings me right back to that. Well, let's see, x squared plus 8x plus 16. That's what I get when I do that. Nice square. And if I subtract 16, you're saying it's just another way of writing it. Yeah, I know a guy named Mike the T-Chef once, and he said the equal signs, you want to think of it as may be written as. So the calculation x squared plus 8x may be written as x plus 4 squared minus 16. Well, how do I know that's really true? Don't call me names. Okay, I'll use a number. Any number? Any number in here? Because you really got to play with numbers to understand algebra. How about I pick 10? That's 100 and that's 80 if x equals 10. And you're saying if it's equal, then if x equals 10, that has to be true. I don't know what 10 plus 4 is. That's 14 times 14. God, I think it's 196, but let me see. 4 times 4 is 16. 4 carry the 1 is 5. 4, yeah, it was 196. And you're telling me 196 is, they are the same. So I could use either calculation if I was solving something. So if I was solving something like x squared plus 8x equal 9, 10, 11, 12. How about 17? Because I don't know what works there. 2, 4, 6. 2 doesn't work. 1 doesn't work. That's 9. That's a hard one. You say use the other side? Okay. Oh, yeah, you know, I think I've learned something earlier. I learned about inverse operations. So you're saying I can apply that here? I can say that that's 7 and that's 7/5. Oh, and I can do that quickly without having to do +1 +1. Wow. Geez, I mean, I can even look at this and say, when does that equal 0 and x equals 1/5? Wow. Boy, I can use that skill here. Oh, okay. Well, let's try it. Let's add 16. Let's take the plus minus square root of 33. Oh, and let's add 4, make it -4 on the other side. Oh, you know what? You're right. That is a good skill to know. So completing this square, that's great. I don't know why you wanted me to do that. Oh, you wanted me to write a squared plus b. That's where we started, right? And you're saying that somehow I can do that for x squared plus 8x plus y squared plus let's make it minus 10y. And let's get something nice over there. 15, 25, 41. You're saying if I make that equal to 8, that I'm going to continue to take this forward to new worlds? Start 8, 25, 16. This is this. You're saying I can explore more things? Oh, but that's not a squared plus b squared c squared form. Don't call me names. I can, okay, I get it. Completing the square, I can make that happen. All right, so let's do that. Let's make this x plus 4 squared minus 16. And let's make this one y minus 5 squared minus 25. Let's set that to 8. Big deal. Oh, you're saying get the constants on the other side? Okay, I'll do that. I've learned how to do that from earlier work. So you're saying x plus 4 squared plus y minus 5 squared equals 16 and 25 is 41. 41 and 8 is 49. Oh, all right. I might have an idea where you're going with this. Yeah, because 49 is 7 squared. Oh, you know what? It is in the a squared plus b squared equals c squared. The last one was a circle with a center at zeros. This is a product? You're telling me make it 0 again? You're telling me to do that? And Rene's yelling at plotting again? Oh, he wants me to plot it? Oh, well, what makes this 0? -4 is a critical number here. Yeah, so I got to figure out how to get 7 squared out of it. Don't discriminate. -7 squared also. Well, I see 12. I see -2. And you should look at that long enough till you see it, or you won't see it. You won't get it. Yeah, so I can look at -4, and I can look at +12, and I can use those numbers to get 49 in this equation. And I can use -4 not to discriminate against negative. -2, excuse me. So y value, what am I doing? I'm using -4 because, oh yeah, I want to keep that. Oh yeah, I want to keep that gone. Get out of here. Yeah, get out of here. All right, -2. Wow. You know what? There's a number right between those two. It's 5. I wonder where 5's hiding. Yeah. And you know, there's a number in a circle between the top, which appears to be 12 right now. That is, if we let -4 work in this equation, then -4, 12 is right there. And it looks like -4, -2 is right there. Looks like 5 is right between the two. Geez, I wish I could see that without having to do all the work. Boy, maybe I can look at this equation a little more quickly and easily, quite carefully. Oh, yeah. -4 and +5 make, just like that last circle we did, the center. 0, 0. In fact, if we just think about that little branch as the x-axis, then it looks like this one's a little longer by adding 4 units to it. It's almost like a new ruler that measures change from -4 instead of from 0. Well, so much to consider here, so much to learn. It's a good thing we got the whole semester to keep doing these problems. Yeah, so you know what I think's going on? I think this circle has a radius of from 5 to 12, 7. Sure wish I could see where that happens. Whoa, geez. So I guess if this is 49, and I want to find the radius, I guess I gotta take the square root of that. Plus and minus, because it goes up 7 and down 7. But down 7 is a distance, so we'll just keep it +7. And 5 minus 7 is -2. And it looks like we're right back to Pythagoras, back to you, Pithy, where this is the side of the triangle, and this is the side of the triangle, and that's the radius. And as one gets longer, the other square area has to get smaller because they both have to add up to 49. Yeah. Yeah, we practice in Pythagoras. We're practicing this. Not this problem yet, because this is too complicated. It's too hard. Right, but we're practicing missing sides, right? If that's 3 and that's 10, then what's that? Some people have really just look at 100 minus 9 now, and they know it's the square root of 91. They can do it in 5 seconds or less. Some folks are still trying to learn. Some folks are still trying to learn. You know, that that's 100, that's 9, and that's got to be 91 because these add up to that. This one taken away from that gets you that. Take this away from that gets you that. And then we know that this is the square root of 9, and this is the square root of 100, and this is the square root of 9. So many things connected from one problem to the next. Hard to keep track of them. What are you saying? Oh, keep practicing and you'll see it. Oh, so don't stop looking at it until you see it? Ah, okay. Oh, so you want me to practice another one? Oh, okay. And you want to pause? You're telling me to pause the video because I'm in a screen? I mean, I talked about walking around and I'm in a screen right now. Oh my God, I'm captured in the screen. Oh, geez. This is frightening stuff. Now I know why people have trouble with math. That's scary stuff. Right? You said it doesn't have to be scary? Okay, let's try one. Let's try x squared minus 6x, and let's try y squared plus, let's do 10y again, and let's let that add up to something that's a user-friendly number. I can do that. Yep, I can call it 2. And you say, change the way it looks. Yeah, that's hard. I don't want to cover that up now, even though they're both products. That's kind of hard, but maybe I can write it a different way. You're telling me, pause the video and you try to do it. Find the center of the circle and all the coordinates on northeast, south, and west. All right, I'll do it. I'll do it right now. And you're trying to pause the video and do it on your own. Yeah, and I'll just do that. X minus 3 squared plus y plus 5 squared equals 36. And I didn't forget the squares. So you're telling me that this has got a circle with a center at 3, -5. And I'm traveling up the square root of 36, which is 6, which makes this 3, -3, up 6, makes that +1, down 6, makes it -11. And you're telling me I can go 6 over, which makes that 9, -5. And I can go to the left, take away 6, and my grandson would be happy to know that that's -3, -5. And you're saying all of those coordinates plus a billion others work? I can't believe it. I'm going to try 9, -5. 9 and -5. And of course, those have been moved over, so I should have done it here. So 9, -5. That's where I can see it easier. And that is, oh, that's 0. I can erase that. 9 -3 is 6. Oh, It's true. Wow. Boy, I can write the equation of a circle now. Can you? Let's try one more. Thank you, Pithy. Say hi to your friend Rennie down there. What? You telling me to say hi to him myself? Let's not go there. Let's go here instead. Let's go x squared plus 4x. Let's go y squared minus 12y. Let's get bigger. All right, yeah, let's go. And let's go 24. All right, you have a go at it. All right, and I'm just gonna keep talking, and I'm just gonna do it. You can watch the process, and I think we'll add it to our list of things that you can do before December 15th. X plus 2 squared minus 4 plus y minus 6 squared minus 36 equals 24. Sure looks to me like I got x plus 2 squared plus y minus 6 squared equals minus 40 on the other side is positive 40 is 64. Wow. And so you're, I guess, looking at a circle with a center at negative 2, 6, because those don't work. All right, if I put negative 2, 6, I get 0 plus 0. I don't think that's equal to 64. But what does work? Oh, what does work is making that 0 by saying y is 6. Oh, so right here, y is 6. So y over here is 6, 2. That hasn't changed altitude. And y over here is 6. And so all I'm missing is figuring out what goes with it. Wow, I'm better off looking here this time. Last time I looked there, I'm not making that mistake again. I'm going to look right here. That's gone, just like the standard form of a line. And I want 64, so I need 8 squared. Oh, so that's 6. Yeah, 8 squared plus 0. That's true. I could have gone the other way because you're teaching me not to discriminate against negative numbers. I can go backwards. 8 units, you're saying? Look here. Oh, that tells you how much you move from the center. Up 8, down 8, left 8, up 8. Oh, no. So up 8 means that that's 14. Down 8 means that that's negative 2. Moving 8 units to the left is minus 10. You're telling me that's true. And moving 8 to the right, we already proved that's true. And moving 8, not moving horizontally means that that's true. And that means that that's true. So sometimes I don't want to move vertically, and I can solve horizontally. Sometimes I don't want to move horizontally, I can solve vertically, but I did it there again when I should have done it there. Boy, if I keep up with this, I'll never do it there again when explaining this. I'm going to hop right there. Beauty of repetition. Okay, we got another something on a worksheet that, you know, I hope by December 15th, you can do that in 30 seconds or less. Why don't you try? Let's time it. All right, let's see. I'm going to go through it. Once I write it, I'm going to go through it. And this time I'm not even going to try to find a friendly number. I'm even going to do it with tougher numbers. All right, I'm just going to throw a number out there. All right, I'm going to try to steamroll this thing. All right, and even employ some things, some techniques that might even be quicker. So let's go. Okay, I'll write x squared plus, I don't know, 6x plus, I'll keep those numbers pretty basic, minus 10y. Equals 7, and I'm not looking at it yet. All right, but get your stopwatch ready. Bingo, bango, bongo, go. Well, I got x plus 3 squared minus 9. I'll put my 9 over here, make that 16 right now, plus y minus 5 squared minus 25. So add 25, and I've got 35, 41. So now I know that I got a center at negative 3, positive 5, and I know that that's horizontally not changing, negative 3, comma 5 plus the square root of 41. Over here, I've got 5 doesn't change. And I've got so negative 3 plus the square root of 41. Comma, get through that, and therefore this doesn't change horizontally. So negative 3, 5 minus the square root of 41. And over here, I'm going to go back 41. So I got minus 3 minus the square root of 41, but the altitude doesn't change. And I guess I'm done. I don't know how long that took. I didn't like having to work with that. It was much easier when it was a simpler number. But you know, lots of circles. You know, there's lots of circles out there, and I guess there's a way to look at the, you know, the rock falling into a pond. Circle moving out. There are other applications that things go out, but we don't want to talk about those, but people do. And you even talk about the rate at which that's changing. When you get to calculus, that's what I'm saying, you get to calculus and you talk about how it's even expanding and at what rate. Oh, you said you can, but in order to look at that, you have to understand this. Oh, so you're saying that future study is based on all the things you're studying right now? Thank you, Pythagoras. I appreciated your help today, I think. What? You're saying Rene went to the cafeteria and somebody asked him if he wanted a drink of water? And he said, I think not, and disappeared? Oh. Okay. I'm going to think not and disappear.